Hello, Mr. Schultz here, coming to you live for another unit review. So without further ado, I'm going to turn my video off so y'all won't focus on me and focus on the review. Let's get started. So in Unit 6, it was all about triangles. Some of y'all think got tired of triangles. But anyways, that's a different story. So for the review, first, it asks us to find the length of segment AB. So here's AB right here. Now, obviously, it's not wanting you to say 4z minus 4. It wants you to actually give a length. But what do we know about those? This side. Well, that side is equal to this other side that's shown by the tick marks. Actually, all the sides are equal, but we don't need to really know that. We just need to know that these two sides are equal. So to solve, you would say 4z minus 4 equals 3z minus 1. Move your 3z over. I would give you z minus 4 equals -1. Add your 4. Gives you z equals 3. Again, it's not asking for z. It's asking you to find the actual side. So now we have to plug it in. AB equals 4 times 3 minus 4, which gives you 8. There we go. Number 2, ask you to find the value of x. Well, again, I notice that all of my sides are the same. Since all my sides are the same, that means all the angles are the same. And they all have to be 60. Like, well, why 60? What told you 60? How many degrees are in a triangle? There's 180 degrees in a triangle. How many angles have to be the same? 3. 180 divided by 3 is 60. They all have to be 60. So to solve for x, we can say 45 plus 3x equals 60. Subtract the 45 over. It's going to give us 3x equals 15. Divide by 3, and we get x equals, what's that? 5. And that's all they ask us to find. It's just x. So x equals 5. Okay, number 3, find the value of x. Well, if I look at my triangle, I see two sides have to be the same. The angles across from those two sides have to also be the same. Or this is an isosceles triangle. This is isosceles. There we go. Which means two angles have to be the same. Well, it's not going to be D because D makes the two legs, or the two legs make D. So that means E and F have to be the same. So to find X, we can say 3X equals 69. Divide by 3, and we get X equals 21. And that's all they ask us to find, is to find X. Number 4, they ask you to find X. Well, again, here we have a triangle that all the sides are the same. If all the sides are the same, that means all the angles are the same. Well, let's just ignore that for a second. There's how many degrees in a triangle? 180. They give us our three angles. X plus X plus X equals 180. If I combine those x's, it gives me 3x equals 180. Divide by 3, and we get x equals 60. Now, this would have been quicker had we done like we did in number 2 and said, wait, all sides are the same. That means each one of these has to be 60. And then we'd have been done. X is 60, done. But some people don't remember that, and that's okay. That's why I worked it out like I did. Okay, for these next 4, they give us that KLM is congruent to DEF. And then we have to identify the congruent corresponding parts. Now, 5 asks us about KL. Well, KL is right here. So the one that goes with KL would be DE. They have to be in the same order, same spot, and everything. So DE. Now, 6 asks us about DF. So DF. Again, it has to be in the same spot on the other triangle. So KM. But Mr. Shull, can I put MK? No, you can't. D goes with K, F goes with M. Has to be in that order. Okay, so then number 7, angle K. What goes with angle K? Okay, and D go together. No, not K and K, really. K and D. There we go. What about F? So F and M. So F is congruent to angle M. Okay, next one. State whether the triangles are congruent by side, 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 angle, side, angle, side, angle, 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 side, HL, or not congruent. Okay, so remember on these, you want to take like an inventory. So for number 9, if we take an inventory of what all we have here, I see 1, 2, 3 sides. Do we have one that deals with 3 sides? Yes, side, side, side. So this one is congruent by side, side, side. I don't like how that looks. Okay. 10. I see 3 angles. Now, some of y'all want to say, oh, A. And that would be wrong. Do we have one up here in our options that say AAA? No. So this one is not congruent. Number 11. I see one angle and one side, but also we have some vertical angles here that we can mark. So what do we have? We have 2 angles and 1 side. So we have 2 options because there's a ASA or there's a AAS. So there's 2 options here that it could be. Well, where is the side? Is the side in between? I'm looking at my side. Is it in between my 2 angles here? No, the side is not in between the 2 angles. So this one would be AAS, angle, angle, side. Okay, 12. Let's see what they have. I see a right angle. The long side across from the right angle, those are congruent. So I see our hypotenuse. And then these are our legs. So how are these 2 congruent? HL. Okay, number 13. First thing I see is some vertical angles. Any place there's an X, there's vertical angles. Okay, so there's that. Now let's see. I see 2 sides, 1 angle. Where is the angle at? Is it between the sides? Yes, our 2 sides meet to make the angle. So which one has the angle sandwiched in between 2 sides? That would be side, angle, side. $14. Again, I see an X, so I'm gonna mark it. Now I also see a right angle. If I look across from that right angle, is the leg, do I know anything about it? or not the leg, the hypotenuse. No, I do not know the hypotenuse. So no to the hypotenuse. So we can't use HL. HL is gone. HL cannot be one. Okay, so let's, if it can't be HL, then we've got to see what else it can be. What do we see? We see two angles. And one side. Is the side between the two angles? Yes, it is. So this would be ASA. Angle, side, angle. Okay, so that's triangle congruence. 15, ask us to find the length of BD. So they want the length of this whole thing right here. Let's see. DC is 3.7. That means BC has to be 3.7. So the whole thing is going to be 3.7 plus 3.7, which gives us 7.4. So BD is equal to 7.4. $16, ask us to find the length of JL. There's JL. Oh. KL is 7.9, so that means JL has to also be 7.9. So there we go. That's all there is to that one. JL is 7.9. Okay, so there's page 1 of the review. So we had equilateral and isosceles triangles. We had a little bit about congruent triangles in general, congruent shortcuts, perpendicular bisectors. Now it looks like we have an angle bisector because they tell us that the measure of angle SRT, so this angle, is congruent to the measure of angle URT. That angle. So those two are the same. So that means RT is our angle bisector. So ST and UT have to be the same. They want us to find UT. Well, ST is 36. That means UT has to also be 36. And we're done. UT is 36. Okay, number 18. It says line YV is the perpendicular bisector of segment XZ. What is the value of n? Well, if we have a perpendicular bisector, that means like xy and yz have to be congruent. So in order to get n, then we need to set them equal to each other. 8n minus 9 equals 3n plus 5. Move the 3n over. It'll be 5n minus 9 equals 5. Add 9 to both sides. We get 5n equals 14. Divide by 5, and we get, it's going to be a fraction. So you can leave it as n equals 14 over 5, or you can say that it's 2.8. I'm just going to double check my math here. So move that over. And if we wanted to check, because you're like me, you're like, should this be a decimal? Plug back in. You can always plug back in. So 3 times 2.8 plus 5, that's 13.4. Okay. 8 times 2.8 minus 9, 13.4. There's your answer. So n is 2.8. That's it. Each of these, if we plug back in, would be 13.4. So that means, yeah, we got it. It's just going to be a fraction or decimal or however you want to write it. Okay, for the next 4, they ask us what term accurately describes segment TY in the diagram. Is it a perpendicular bisector, angle bisector, median, or altitude? And you're going to use each of these once. So there's like, yeah. Let's look at 19. So to be a perpendicular bisector, it has to intersect at a right angle. Does 19 do that? No. To be an angle bisector, it has to cut the angle in half. Do we know that 19 cuts an angle in half? No, it doesn't give us little marks up here or anything. So, no. A median starts at the vertex and then divides the other side in half. Does this do that? Yes, so this could be a median. Does it intersect at a right angle? No, so it can't be altitude. This is a median. 20. Okay, so perpendicular bisector, does it intersect at the right angle? No. So that one can be thrown out and altitude can be thrown out. It's either angle bisector, and we've already used median, so it does divide our angle in half. So yes, this is an angle bisector. Okay, 21. So now we're left with our 2 right angle ones. It's either going to be a perpendicular bisector or an altitude. For 21, does it divide a side in half? No, so it can't be a bisector. This is an altitude. (22), it does divide a side in half and intersects at a right angle. So this is a perpendicular bisector. You could also argue that this is a median because it starts at the I just lost my train of thought. Starts at a vertex and then divides the other side in half. So yes, you could also argue that this is a median. But by far, this perpendicular bisector, this is your best answer. That's the best answer. You could argue median, but perpendicular bisector is your best answer. It does more than just cut the other side in half. So something to keep in mind there. Okay, for these next three, we're going to be talking about mid-segments. Of these next four, I should say. Talking about mid-segments. So the first one, they ask us to find the measure of angle BCZ. So where is BCZ? BCZ, that's this angle right here. Well, if I extend these lines out, and we just ignore the rest, just focus on these. What relationship, of course, I can't draw a straight line, so hang on. What relationship does this angle have with our 42 degrees? These have to be congruent. These are alternate interior angles. So they're congruent. That means angle BCZ is also 42 degrees. Now, a lot of people want to say things like 32.4. No, you see, do you see how, if I erase this and move it up there? Hang on. Now I'm erasing everything. Really? Hang on. Do you see how this has a degree sign on it? That is an angle. Does 32.4 have a degree sign? No. Does 70.2 have a degree sign? No. Don't even use those for this problem. These are sides. 42 is our only angle. So, with all that being said, these are both the same angle. They're both congruent because they're alternate interior angles. So BCZ is 42 degrees. Okay. 24, ask us to find BC. BC is going to be this one right here. Now, this is a mid-segment. to get from a mid-segment or from the side, if I go to the outside wall is 70.2. To get inside, I have to divide that by 2. So I would do 70.2 divided by 2, which gives me 35.1. That's what BC is. BC is 35.1. Then they ask about XC. XC, that's that one right there. That's half of a side, half of a full side. Where is that mid-segment at? That's that 32.4. Well, 32.4 is half of that side. So this piece is going to be 32.4. While we're at it, we might as well say that piece is 32.4. So XC is 32.4. It asks, what is XZ? Well, that's going to be 32.4 plus 32.4, which is going to get us 64.8. So that's XZ. 64.8. Okay, keeping it moving. 27. Write the angles in order from smallest to largest. So now we're doing angles. So we want to look for the smallest side first. Here's our smallest side. If I go across from it, I'll end at my smallest angle. It's going to be angle F that comes first. Then I'll look for my next smallest side. It's going to be the 7.1. If I go across from it, I'll end in my next smallest angle, which is angle H. And last but not least, that leaves us with angle G. So F, then H, then G. Now for 28, we're going to go the other direction. We want the sides. Sides need 2 letters. Don't just say, oh, A, B, C. Great, you can put the angles in order. It doesn't ask for angles, it asks for sides. So our smallest angle is A. If I go across from it, where do I land? I land at BC. Okay, then my next smallest is this 46 degrees at 2. If I go across from it, where do I land? Land at CA. And then last but not least, the biggest side. across from the biggest angle. And that's AB. See what I mean by we need 2 letters for each side. Okay. Now they want us to tell whether a triangle can have sides with the given lengths, and we have to say yes or no. To do this, we need to add our smallest 2 sides. So 29 asks us to do 3, 7, and 10. So our smallest 2 are 3 and 7. So 3 plus 7, that gives us 10. How does that compare to the 10 that's given to us? It's equal, so this is not a triangle. Not a triangle. No, 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 no. Not a triangle. Number 30, our smallest 2 sides, 11 and 14. So do 11 plus 14 gets us 25. How does that compare to our largest side of 20? It's greater than. So yes, this is a triangle. And then number 31, add your smallest 2. 6 plus 8 gives you 14. How does that compare to your largest side of 16? It's less than. Can we be less than? No. You have to be greater than in order for this to be a triangle. It must be greater than. Anything else? Then no, it's not a triangle. Okay, number 32. For 32 and 33, we have to use the less than, greater than, or equal to symbols to compare each of the following. So first they ask us about angle T and angle C. Now, in class, I said, go and write those down here. Angle T, leave a space, right angle C, and then compare them. So T is right here. C is right here. If we look across from those, 6.6 and 6, which one's bigger? 6.6 is bigger, that means T is bigger. So T is greater than C. Okay, 33, ask us about ST and KL. Again, go on and write them down here. ST, KL. ST is right here. KL is right there. If I look across from those, ST, I'll land at 44. KL, I'll land at 75. 75 is bigger, so that means KL is bigger. If they were the same, then they'd be equal to. We didn't see one of those, but that's how it goes. If they're the same, they're equal. So, okay, for 34 through 36, this says, they say use cross products to solve. Typically, we say cross multiply. Same concept. Some people call it the butterfly. Either way, no matter what you call it, the process is the same. You do 16 times A equals 8 times 10. Eight times 10 is 80. Divide by 16. And you get A equals 5. There's our answer. Okay, next one. I tend to go for the variable first. So 3 times B equals. Go along the other diagonal. 9 times 2. 9 times 2 is 18. Divide by 3. And we get B equals 6. There we go. And then we have number 36. Again, I tend to go for the variable first. 3 times X equals 5 times 6. It's going to be 3x equals 30. Divide by 3. And we get x equals 10. So that's doing the cross products. Now let's look at 37. Says the ratio of side lengths of a quadrilateral is 3 to 4 to 5 to 6, and the perimeter is 216. What's the length of the shortest side? Well, let's write down our ratio and kind of leave some space here. Down here, we're going to put our blanks in. And together they said this had to equal 216 centimeters. Now, if we add up what they gave us, 3 plus 4 is 9, or no, 7. 7 plus 5 is 12. It's going to be 18. So I have to figure out 216 divided by 18 gives me what? It gives me 12. So 18 times 12 is 216. That means I need to multiply everything by 12. Three times 12 is 36. 4 times 12 is 48. It's going to be 60 and 72. Then we've got to check to see what they ask for. They ask for the shortest side. My shortest side is 36. So this would be 36 centimeters. There we go. And the last one, they say the ratio of angle measures in a triangle is 3 to 10 to 12. What's the length? What's the measure of each angle? Again, write it down. 3 to 10 So 12. And we're talking about the angles in a triangle. So together they better equal 180. Angle measures in a triangle. Those equal 180. What do they give us though? 3, 10, and 12. That equals 25. So I have to figure out 180 divided by 25 gives us what? It's going to give us 7.2. So that means I have to multiply everything times 7.2. That's going to get us, let's see, 21.6, 72, and 86.4. Okay, what's it ask for? It says, what's the measure of each angle? So in that case, we just list them. 21.6 degrees. 72 degrees. And 86.4 degrees. There we go. And if we wanted to check, we could add them up. And yes, they give us 180. Okay, so that's the review. Study it, know it, and good luck on your test. But more than anything, remember, you are awesome and you are created to do wonderful things. Always believe.